Mike Matchett with Small World Big Data. We are here today talking with Verge.io about this concept of virtual data center. What does that really mean? Hold on and we'll find out in just a minute. I've got Ness here, who is going to tell us all about what Verge.io is up to, namely virtual data centers. It's a concept that some of you might think that you already kind of understand, but believe me, there's a lot to learn about the opportunity here with virtual data centers. So let's dive into it. Welcome, Jan.
Thank you, Mike.
All right, tell us a little bit about Verge.io. It's not necessarily a new company, right?
No, the company was actually originally founded 10 years ago. It was called Yottabyte.
Yeah.
Yottabyte was a software-defined storage company, one of the first ones, in fact. And just so everybody knows, a Yottabyte is 1 trillion terabytes. It's a lot of data.
And we're about to reach that, I think, on just even in my taxes, I think I've got it. Anyway, so Yottabyte did a lot of software-defined storage used in use cases that we might have called hyperconvergence. But we're beyond that now. We're going for something bigger. People are wanting to do a kind of convergence of basically the entire data center, right? So what is now Verge.io's What's in there? What's in your arms? When you put your arms around what Verge.io does, what are you encompassing?
Yeah, so the way we describe it is it's virtualization software that virtualizes the entire data center. It does to that data center stack, think, bit storage to BGP and DNS, and it virtualizes all of that, just like how VMware virtualized the server. And basically what happened was this company called Yottabyte 10 years ago invented this software-defined storage product that was really groundbreaking and had this underlying global deduplication. And what Verge is, we added one more invention to that, and that is the encapsulation of the entire data center. So we virtualized the rest of the stack above the storage and made them so isolated that we now deliver virtual data centers.
All right, and this is going to include our networking. This include the storage you just talked about, and it includes all the compute control and things. Tell me a little bit, when someone's looking at a virtual data center, it seems a little nebulous at one level. Am I thinking the right thing if I'm thinking it's about taking, say, everything that a VMware cluster would be running and now making that itself virtual? Would that be kind of a way to think about it?
It's a little bit even more broad than that.
Yeah.
So imagine taking your SAN, either software defined or physical. You got then hosts that run your hypervisor. Then you might have, a switch. Then you might have a Fortinet firewall or security device. Then you might have a router, a Cisco router. Then you might have some replication software to replicate everything to another location. Then you might have some orchestration and automation tools. Then you might have sort of logging and monitoring tools. Take all of that away and just put, Verge is an operating system. Install our operating system on a couple commodity servers, grab the mouse, and you create virtual data centers that have all those things I just described to you.
All right, so it's going to have, with just a couple of commodity servers, I can create virtually SAN. I can create sort of the shared multi-user environment. I can, I believe you at one point you could even, when looking at it, create nested environments, right?
Yeah. So this second innovation around data center encapsulation, what's cool is that our founder he virtualized everything, and it's so encapsulated and so independent that you can nest these things. So yeah, you can have a big virtual data center and say, I'm going to put all my HIPAA compliant activity inside there, and then inside that virtual data center, let's say that has a certain amount of storage, CPU, GPU, and memory, pool to it. And then they can slice it up and say, well, I've got customer one has this HIPAA thing, customer two has this. They can each even be branded as their own brand. So for channel plays in the service provider world, but each one of these things are so independent that you can pick one up and move it to another location, another Verge instance, drop it there and start it. And as long as you're using our DHCP and have some kind of connectivity back to the original host, you don't even need to re-IP anything.
All right,
Each
wait.
virtual
Hold on. So we're just talking, first of all, about taking a couple commodity servers and turning that into a data center where it's got basically a virtual SAN, the virtual networking equipment, the security that a whole data center would have wrapped around it. And now you're just talking about portability, because once I have that virtual defined in software, I can replicate it, back it up, and or migrate it, or move it, or clone it just at will.
Yeah, same thing you would do with the virtual machine in VMware. Start it, stop it, clone it, copy it, write software that will modify it. And but imagine being able to do that to everything in your stack. So when you take a snapshot of a virtual data center in our world, maybe it's a snapshot that has 50 VMs in it, 25 Windows, 25 Linux, a bunch of SQL Server, whatever you're running there. And it's a pretty active workload. You can snapshot the entire virtual data center. That's going to snapshot all the networking, all the DNS, all the firewall rules, all the replication rules, all the recipes, all of everything, all the logging, all the monitoring that you have set up. It's going to snapshot the entire thing. You can go over to it, click on it, and start it. You can snapshot that thing in milliseconds. Then you can go to it, click on it, select all on the 50 virtual servers, and click start, and it will start them all. You can take that thing, snapshot it, replicate it to another data center, and do the same thing. Because it's kind of like what VMware did to the server. It's this isolated, virtualized thing that you can pick up and move around.
So it becomes its own I don't say tangible object, but its own thing that you can manage as an object that's portable and move around. There's going to be a lot of questions about this, no doubt. So let me go in a different direction a little bit. Let's talk about use cases and complexity and things. So if let's talk about the small end first. So say I'm setting up just kind of a small remote office. What do I do, and what are kind of some of the pain points and savings I'm going to get?
Yeah, good question. So we run really well in small environments because it's a very, very thin piece of software. It's one piece of software. So we have it's sort of kind of like edged, if you want to call it, deployments, which we have some of. They'll take two very, very small, simple commodity x86 boxes. Don't even need a switch. Make sure there's two network ports in each. Install the OS on both boxes. Have a cross connect between them. Take your two internet connections or WAN connections, whatever they are, plug them one into each box, and you have nested multi-tenant virtual data centers. So now take your virtual data center you've defined up at corporate that has everything set the way you want, security profiles, replication, DNS, everything is set up the way you want. Pick it up and drop that virtual data center on that location that's a long ways away. And we have some self-healing, automatic self-monitoring technology. It automatically modifies SAN queue size to maximize throughput. So you don't need a storage engineer because you don't have one out there. And so not only does it encapsulate the data center, but we built a bunch of tools because the whole thing is encapsulated and it's a bucket of bits now. We can write algorithms that help make that whole data center run better and faster over time, depending on what it's doing, without having to have an engineer there.
Okay, so you just introduced another thing where your software is getting better over time because it's learning what it's doing and analyzing what it is. I don't even think we have time to go into that, but that sounds even like a whole nother hour. I just want to keep on this track for now, though.
Sure.
So let's talk about a bigger customer, somebody that might say like, hey, I've got a larger enterprise and I might be running a big VMware cluster or a big Nutanix kind of hyper-converged outfit. If they're looking to say, I want to go more commodity route. I wanted to commoditize the hardware, but I also want to now start to think about commoditizing, the software stack that I'm using and collapsing it, converging it in the ultra sense that you guys talk about. How does that look?
Yeah, so we actually, this is, I know this is going to sound like we try to do everything for everybody, but originally Yottabyte was designed for massively scale out capability. That's why they named the company Yottabyte. They can, to a snapshot, our technology can take a snapshot of a petabyte of data. So we actually work really well at scale. We have beaten many of the big boys because they have limits in number of nodes per cluster, number of, it's too easy to, two problems that happen at scale. You bump into some limit that feels a little arbitrary and you couldn't really know about until you got there, number one. Or number two, as you as you want to scale, you have to scale everything in proportion. Like you can't just add more storage. You can only add, storage and memory and CPU have to be at a certain ratio. So the ability to scale, to first of all have almost no limits. Second of all, scale out your hardware resources independently. We liquify what's underneath us, and is really advantageous. And the third thing is, and this is also part of the original Yottabyte technology, is the more storage nodes you add, the more data IOPS we can deliver. So we don't end up with that problem where, hey, you need to buy another SAN or another controller. You got a ton of storage, but you're running out of IOPS and you have a bottleneck in your throughput. We do not have that problem. So we do really well at scale. We have customers running pretty large, very large environments with 1,500 virtual data centers nested in very fashion, doing very, very high-end medical research and all kinds of things. And they do it with literally 1/3, 1/10 the staff they used to have.
So a lot less specialized equipment because it's all software defined stack. A lot less specialists because you can sort of define it once and replicate that in a lot of different places or copy it down or inherit it. A lot of object-oriented kind of thinking clearly has gone into this, Jan. We see that. Tell me a little bit about the kinds of resources we can do. I understand that you've recently expanded into serving out things like GPUs and stuff. What can someone expect to virtualize?
Yeah, so what we want to do is take underlying expensive or commoditized hardware and virtualize it so that you can get the most use out of it by allow you to run as close to hardware speed as possible. So we recently released a GPU capability, which you can do in other converged environments, but you add that to our ability to encapsulate and spin up and spin down entire virtual data centers that can have vGPU and GPU resources in them. It allows you to get better use of those across multiple more hours of use a day.
Uh-huh. So is NVIDIA appreciating the fact that you're leveraging their hardware wider for people, or are they sort of annoyed that people might have to buy as many GPUs for every situation?
Yeah, well, I mean, they're a phenomenal company. We work very closely with them because to do the vGPU capability was actually quite difficult and required their work and does require licensing from them. But
okay,
if they even notice us, that'd be great.
We'll put in a good word for you. With that.
Thank you.
All right, so this is some very cool stuff. There are so many things we could talk about and get into because we've just opened kind of a Pandora's box. When you say virtualizing a data center, there's really no easy way to talk about it in a few minutes because even just talking about the old Yottabyte storage and what's happened with that and the global dedupe, I think we could spend an hour on, much less what you're doing here. But the idea that we could now take a stack of commodity hardware and build out virtual environments that are themselves fungible and migratable in that virtual data center way, and we don't have to necessarily pay the VMware tax, and we don't necessarily have to pay the hyperconvergence overheads that come with some of those hyperconverged stacks from some of the players on there. That this is now a complete software solution that drops on that is pretty cool, Jan.
Thank you. I'll tell our founder.
So I guess in lieu of that, I would just ask you if someone is interested in finding out more information about Verge.io, how Yottabyte's gotten there, how the different, how can they get their hands on it, try it out, and so on. What would you have them do first?
Yeah, so go to our website, www.verge.io. And you'll see a bunch of videos there. You can look at videos of us doing an installation, how easy that is, us doing an upgrade, how easy that is, using the dashboard, how easy that is. And then there's two things you can request right there. We'll give you we have a bunch of hosted infrastructure. We'll turn over a virtual data center to you and you can go at it and see what you want. It runs in our infrastructure, or we'll give you a copy of the software. Reach out. For kind of a community edition. We love it when people get their hands on the software. It's kind of like the first, I know it sounds weird, it's kind of like the first time I held an iPhone. I was like, this is going to change everything.
This is going to change everything, Jan. I like that. The liquefaction of the data center, turning everything into the virtual data center and making it ability to, I mean, converging it ultrally. I'll give you that one, ultra convergence, and the ability to basically spin these up, nest them, do whatever you want with them, and at the click of a button because of that underlying technology that is really effective at global deduplication and everything else. It's
Mhm.
oh, there, cool. Thank you very much for being here, Jan. I look forward to having you back and explaining some more of the technologies here at some point. So do come back.
Get our founder, CTO out here, and man, you can't shut him up. He'll tell you all about it.
All right, all right. With that, take care. Check it out, guys. All right.
Thanks, Mike.